And it doesn't say, but that is always the case. We always have to look for the x and y intercepts, always. It's part of the graphing process. Is there anything else you would like to go back to? Do you have any questions about this? Anyone? Anyone?
I have a question.
Yes, I'm ready for all your questions. Yes.
Okay, so for the WebAssign, so we are answering it and submitting in the WebAssign, and we are in the canvas, we are showing our work on paper.
Exactly how we just showed it. Yes.
Okay, and would you like the work shown for every problem? Because some of the problems.
Yes, some problems, if you just read from the graph, then there is nothing to write. Yes, I agree.
And would you like us to write down the question or like?
You just very good question. Yeah, that if you use the template, you don't have to write down the question, but I'm gonna make it as easy as possible on you. So we just say graph. If it's the graph, and I'll understand, I'll see what you're graphing.
Okay.
Just something short. I don't want you to have to spend hours and hours, and yeah, I want to make it as simple as possible.
Thank you.
Thank you. I think somebody else had a question.
Yeah, hello, that was me. I was wondering if I could see the work for the y-intercept again.
Yes, of course, of course.
I have a question about how you want us to write the domain and range. Do you want it in interval notation?
Yes, very good point. Yes, please.
Okay.
Good. Other questions? Excellent. Anything else?
I had a question. You said there were no asymptotes. What were the asymptotes?
You see it?
Say that one more time.
I'm sorry?
Wait, I couldn't hear you. Could you say that one more time?
Right here.
Oh, I'm sorry.
Do you see it?
No, yes. I don't see it. I see the skill assessment page.
Say that again.
All I see is the skill assessment page, PDF.
Oh. Sorry. You're right. I was sharing my screen. I'm sorry. Right here. Remember, we had a horizontal asymptote for these two graphs was 0. And I have to shift the horizontal asymptote first before I graph the final function.
Okay, thank you.
My pleasure. Anything else? Other questions? Is there anything?
I wanted to see the work for the y-intercept. I missed some two points.
You mean this?
Yes, yeah, awesome. Thank you.
Good. Anything else? Other questions from the skills assessment you would like to go over?
So this is a bit of a long one, and I could just look it up on my own if it's too long to go over. But what would 13 be? Could you refresh me on how to do that?
Of course. This is a super important type of problem. Absolutely. Thank you for picking that. So we have, so this is 13. X minus 1 to the third times 6 times x plus 2 to the third minus 3, x minus 1 squared, x plus 2 to the fourth, and everything divided by x minus 1 to the fourth. Awesome. Okay. So first of all, let's identify how many terms we have at the top. Can anyone identify for us how many terms we see here?
Looks like just 2.
Excellent. Brilliant. Aaron, thank you. This is the first term. And this is the second term. Great job. Okay, so obviously I don't like having a factor like this in the middle of other factors with x in them. So I'm going to put, like here, the numbers go in front. So I'm going to rearrange this as 6, x minus 1 to the third, x plus 2 to the third, minus 3, x minus 1 squared, x plus 2 to the fourth, 2 terms, and x minus 1 to the fourth. I would like you to remember 2 things from me from the very beginning: factor and simplify. So please have these in the back of your mind already. Okay, so I'm looking at the factors at the top, and I'm going to ask, is there a common factor, or are there common factors, both in this and this? And if they are, let's pull them out.
Yes.
Yes, very good. I'm ready.
X minus 1.
So there is a 3. There is an x minus 1 to which power?
3 power.
So we're talking about 3 or 2. Which one?
Second power.
Good, awesome. And then we have x plus 2 also. Awesome. To which power? And we have 3 or 4?
3.
Yes, always the smallest of the 2. And on the side, I have a quick question. If one power is negative 1/2 and the other power is 1/2, which of these 2 is the smallest? Which one? So let's say I have x plus 1 to negative 1/2, and I have x plus 1 to 1/2. I will pull in front x plus 1 to which power?
Negative 1/2.
Of course, always the smallest of the 2. Thank you. Who said that?
Yash.
Thank you, Yash.
Yeah.
Perfect. Okay. So now let's see what is left. From 6, I took a 3 out. What is left?
3.
You mean 2?
2.
Good.
Yeah.
So from power 3, I subtracted power 2. What is left?
1.
1. Very good. From power 3, I took everything out. So I reached the negative sign. 3 is completely out. X minus 1 squared is out. From x plus 2 to the fourth, I remove 3 of those out. And what is left?
1.
Yes, and x plus 2. Mandatory with parentheses because otherwise I may forget to distribute. Good. At this point, I can do this. I removed 2 factors from the top and 2 factors from the denominator. So this is x minus 1 squared. In front, 3x plus 2 cubed. And now I have to perform the calculations. 2x minus x, let me write it first. 2x plus 2 minus x minus 2. Remember, the negative sign has to be distributed to both. So the final simplified form will be 3x plus 2 cubed, and x, because 2 with negative 2 will go away, and 2x with negative x is x. So this is x minus 1 squared. And of course, I will put it next to 3. That's the correct way. So this is x plus 2 to the third over x minus 1 squared. I would like to see this uploaded for me, please. I'd like to see how you wrote it. You don't have to copy this if you don't want to. This was just a side calculation, side discussion. This is not required, but I'd like you to please upload this in the same assignment for today. It takes more than one upload. You already uploaded one. Those of you who just came in, there were 2 students who just came in. I think it was, who was it? Charles and somebody else, I thought. Please, we do have an upload or uploads every class, and the upload is at the top somewhere in Canvas. So please upload this. I'll wait for a minute. And please let me know if you, I'll look at it, Kelsey. I'm not sure. I just saw their text here. Is there anything else you would like to look at from the skills assessment?
If we're not entirely finished.
Sorry, I have a question.
Yes?
So it's about the solving. So inside the bracket, you have 2 and x plus 1. Isn't it supposed to be x minus 1?
Yes, I copied x plus 1 instead of x minus 1. Yes, thank you. Yes. Yes, thank you. Thank you. So don't copy what I wrote. Thank you.
If we're not entirely like finished copying the problem, do we still like submit it, or should we finish copying it before we submit it?
I have to make a correction. Just give me 1 more second so I can make sure what I'm doing here. So it's -2, and that's minus x and -2. Okay, so this has to be corrected. Thank you. I copied x. Why did I copy x plus 1? I talk too much, right? Very clear. So -4. So -4. So I would like you to keep up, and if you have, let me answer your question. If you can keep up, you have to stop me. But we're doing it really very slowly as I can possibly do it. Okay, so please keep up. If you do fall behind, it's okay. Just let me know though. So thank you very much for your correction. So this was x minus 1. Somehow, I don't know. I don't have any excuses. So it is x minus 1. Now I have to go back and check everything. So that was, yes, indeed, x plus 2. So the rest was okay, and minus x minus 2. So I do have x minus 4 here, and x minus 4 here. So now it's okay. Thank you very much.
So you said we have to
Just take a picture as you did at the beginning of the class and upload this.
What did we take a picture of at the beginning of the class?
So you were not here at the beginning of the class?
I showed up like 15 minutes late.
Oh, so you were the second one. So well, that's okay. So just take a picture of this and upload of your notes, not my notes. Take a picture of your notes and upload it at the top module. I'll show you again where. Yes?
Will it allow us to make multiple submissions?
That's okay. You can submit more than once. Yeah.
Okay.
So we go to the module. It's okay. The first one is not graded or anything. We were just practicing. Okay. So here it is. Daily class uploads. Click on this and just upload so I can see what you wrote. If it needs to be corrected, I'll correct it. If there is no need to be corrected, we will get 5 points. Okay, so back to the skills assessment. Do we need anything else from here? Anyone else needs anything? This is what you have to upload and submit in WebAssign by Thursday night. You can ask more questions on Thursday, but if there is anything you need right now, please tell me, because I would like to start chapter 2. Is there anything else you need?
Yeah, I had a question.
Yes? Yes, I'm ready.
No, I was waiting for it to load. I'm looking through right now.
I have it right here. It's on the screen too, if you want. Oh, is it from WebAssign?
No, it's the skill assessment.
Okay. You can look here. I can scroll up and down.
I wanted to go over 19 just as a refresher, if you can.
Yes. So let's look at 19. Sine 2x equals sine x on the intervals 0 to 2 pi. So before we look at this problem, I just want to show you that in all the previous semesters, pretty much the same questions I get, which is, they're okay, right? That's fine. So have the curiosity, and this will help you with your skills assessment that is due on Thursday, by simply looking at all this. Just look at the lecture notes for each semester and see what you need from here. Okay, and then you see it starts 2.1 through 2.2. Okay, so all this lecture notes start with the same thing over and over. So if you're missing any of the questions or if you need more help, the videos are there again for those of you who came in a little bit later. So let me show you how you do this. You go to the lecture notes. Let's see, out of curiosity, let's see what my students asked at that time. I bet it's this problem somewhere, but we're going to work on it in a minute. So no, everything is working fine. I'm not sure why this is doing what it's doing. Okay. Okay, so piecewise defined functions, exactly what we just talked about. Okay, another piecewise defined function and difference quotient. Okay, and that was a different trig equation that they asked about, and pretty much the same thing. So all these examples are extremely useful to look at. And oh, I forgot to show. So if you're interested in any of this, then you will simply go to the video pertaining to this. Again, let me show again for those who just came in or were a little bit late. So all videos work. They are in YouTube. I check them before I delete them from the hard drive. So you only have to do is just click here and go to the part that you are interested in. You can look ahead. You can do whatever you want ahead of time. You can review what's ahead. Okay? So this is what I'm going to show right now for this problem. So you have other references. Okay? And you have 4 or 5 semesters of work. Well, this is a trig equation. And there are, as we know, a lot of trig identities.